Right, let's start. Right, so I'm going to talk about a build tool. And I originally thought I'd just have a vision of what I think how things should go, but turns out I was kind of made faster progress than I thought. So I actually have a beta to show and to demo how I think would be nice to do builds. And who am I? I'm Jan-Christoph Vogt. I work at X.AI. We magically schedule meetings with artificial intelligence. And you may know me from my work on Slick and my years in Martin's lab and the composable record stuff I did and my involvement in Forklift and Maven Search maybe. So what's the goal here with the build tool? I develop open source libraries. I'm working on different projects at work. And well, builds are important for me, and it feels like a hassle often to just write those builds. So I want something nice to replace this. And especially now at X.AI, where we have 25 engineers, a lot of data scientists, they just experiment a lot. They write a lot of small projects. We want to break up our build into smaller things to make it more maintainable. And even though this is like a side project in my free time, eventually it would be nice to use it there as well. And first of all, I would like to target open source and smaller projects and then see where things go with this. Right, so here's what I think CBT is, which is it's made out of few and simple building blocks. It's easy to use, it's fast. It's idiomatic Scala, because you write your builds in Scala. It's flexible, so it's simple, but at the same time not restrictive. It's still flexible, and a very important feature of it is that builds are compositional. And I'll get into that again. And also, which was also very important to me, the code is actually easy. And everybody who has very basic Scala understanding in this room will be able to understand the complete code base. And will not take a long time for this, actually. So it should be easy to contribute. There are other reasons for this. So what are the building blocks? The most important one is that you can compose builds. You can write a small build, have another build depend on this. And this is a very fundamental concept which we will derive a lot of functionality from. Then there is a Scala, like a library written in Scala that has all the basic features that you would need, like putting stuff in a jar file and publishing it to Maven and all that. That's just a library. And build scripts, the build scripts, however, are written, first of all, they're written in Scala code. And the default way how CBT does it is they're classes. So what usually we'll call tasks in builds are the members of this class, the methods. You can call them. And that's how you run tasks. And they can depend on each other. That's it. And configuration happens through inheritance. So you can inherit from the class, and then override certain things to kind of hook in. However, this is a very shallow layer on top of this library. So you can use all the functionality without this class stuff if you want to. It's just one way to configure your build, or the kind of suggested way. Also, I made sure, at least as far as I got to it, that the interface of CBT actually works well with other command line tools. So for example, compile would return the path to the class files, or class path would return an actual class path, which you can pass on to Java or something like that. Whoever has been around in the SBT 0.7 era may recognize the way to configure builds using classes. So this stuff is actually similar. I didn't realize that until a week ago when I kind of talked to Martin. He was like, hey, look at that old stuff. And turned out they made a lot of similar design decisions with this configuration stuff. And different ones in other areas. So how do I get it fast? So I'll talk a little bit of theory first, and then I'll just show the tool. It runs it keeps the JVM running via Nailgun. It caches dependencies, first of all, from downloading them. It comes with its own resolver for Maven. It caches them on disk and doesn't resolve them again when it has them already. And it does cache the class loaders for those things in memory. So when you keep running it again, even the jars for your own project will be resident in memory. That makes a lot of difference in terms of runtime. There's Zinc, the incremental compiler, which also has an overhead, so it kind of guards against running it too often. It does support concurrency for speeding up things in parallel, and I used a different library for triggering automatic rebuilds, like when you loop. That's pretty fast on OS X. And why is it easy to understand? First of all, because it's very focused. I really want to keep it down to the small parts that really make up a build tool and not kind of diverge from this path that could be done separately. I mean, it's libraries. You can plug them together. It's just Scala code, right? It's tiny. It has less than 1,500 lines of code with all the functionality it has. And it's easy code that beginners can understand. And actually, this was more like, the next point was more like a guilty pleasure first, but it turned out to be really useful. It actually starts from source. So you clone the GitHub repository, and then you run a bash script, which the first download Scala jars, uses those to compile the first part of CBT, which includes the Maven resolver and all that, then runs this to download additional dependencies, then uses that, which includes Zinc, to compile the rest, and then it's basically ready to go. And it also detects changes in its own source when you use it, so you can just keep changing it, and it will automatically recompile itself before it recompiles your project. These are the features supported right now: compiling, running, having tests, generating Scala doc, packaging jars, uploading them to Sonatype, downloading jars from Maven, repeating compiling on file changes, and composing builds. And missing there's a handful of superficial things missing, like configuring different resolvers and cross-Scala versions and Scala.js support and kind of jumping to the wrap. Well, even that's not actually true. There's a way to do that. So there will probably be a couple of refinement needed even until a larger audience even can use it for like their simple builds if they want these features, but that should be simple to get in. There are some rough edges because, I mean, I'm the only user right now, so things, yeah, it's only been tested on OS X by me. Like, I know 2 guys tried it on Windows and Linux, and it did work apparently, but I don't know. And the output, the logging and stuff needs to be improved to kind of be nicer, visible, and usability, but it's okay. All right, let's get to it. So we're in a directory with nothing in there, but I have a file prepared here. So the most simple CBT build you can have is you don't write any build files, you just dump a Scala file. So we save the Scala file now, which appears here, and what we can do now is just CBT, compile, and now, yeah, apparently I changed CBT since last time. So it recompiles itself, it kind of stops and restarts Nailgun, and it compiles this, and we'll return the class path. Actually, this, yeah, if you run it again, it will be very quick. That's like, so it's like about half a second, and that's straight from your own shell. It doesn't need its own shell or something for that, which makes it nicely interoperable and startup time and all that. Okay, right. So, right, oh, there's a little bit of convention in the tool. Not a lot, because I think if there's a lot of convention, you have to learn a lot of things, and they can seem very magical in the beginning, but a little bit of convention can help to make things easier. One of the conventions was source files on the main directory and /source in any kind of subfolder there. Another convention is, if there's a class called main, this will be the main class. If you do cbt run, it will run this class. Okay. Yet another convention is if there's a folder test, and in this folder test, let's cut this out and create a new main file here. There is a object main in the tests. If you run test in your main project, it will basically treat the test folder as a build, load it, and run the run method in there, which makes it very quick, even without a framework, to just spit out some tests in the main method. And obviously, this needs to include the main sources, right? So you can do something like, right, so this is the main sources in the main build, this is the test build. So that's how that works. Right, so, okay, this is like the default builds. That's not very interesting. Let's add an actual build to our project. One more convention, if there's a folder build, in which you put any kind of Scala files, I used to call them build.scala, but this will be treated as the Scala files for your build. And in general, it's already compositional in the sense that the test folder, the main folder, and the build folder, they are all 3 builds with exactly the same rules. And each 3 of them, the same rules yeah, hold, which means you could actually write tests for your build script in your build folder, or you could have a build for your test file, or you can have a build for your build file, just because of this composition, and it's easy to do so. Okay, so now let's look at how an actual CBT build script looks like. When you run CBT compile, CBT will check if there's a build folder, and then in there run a default build, but because it's going into the build folder, it doesn't run the standard default build, it runs a slight variant of it, which is one, it's called the build, which, well, builds your build script, basically. So, and one of the things that it does, it gives it the dependency on CBT, so you can access CBT internals within your build script. Yes. So I can do stuff like import CBT dot underscore, and then, which is what I would normally do, and then class build, that's another convention. So if there is a folder build and there are class files in there, it will check for a class called build, and that's your script. That's the one it will run. And it expects a particular format, which is it takes a value of type context and passes it on to whatever build you extend from. In this case, I'll extend from the basic build. There are a handful of different variants of these builds you can extend. There is the basic build. There is, which doesn't allow you to package or publish stuff. There's a package build, which requires to give more information, like the artifact name and a version and that. And once it has that, it allows you to package stuff into a jar. Then there's another one, which is the publish build, which requires even more information for the POM file and all that. And this basically allows you to publish stuff to Sonatype. But right now we don't need that, so we just, let's say we just want some dependencies. Right, dependencies equals super.dependencies. Right, what do we do? Right, do this. Let's do this. Yep. And so I just adopted the same syntax here as SBT, because a lot of people publish their dependency descriptions in this format. So you can have the same DSL here. So now I'm depending on a library, and in my main code, I can now go ahead. Let's make a main thing again in our main code. I can go ahead again. Actually, wait. In the main, that's the main app. I can now import something from this library. In this case, I'll import this method, which allows us to show basically what Scala thinks an expression is after type checking it. Right. Override dependencies. Oh, right. Right, so that's the output that shows, okay, there's this famous can build from and all that stuff. But basically, we just added a dependency to our build. And because this folder build, which is very small, which you can see here, is a build itself, you can do the same thing. It's like, SBT has a similar feature, right, where you can add a build file for a build. And then you can have dependency, which you pull into your build. But it's just standard Scala code. So usually, if you would create like something like plugins, they would be traits which you mix into this build, which you pull in as a just normal dependency, and you just mix it in. And in fact, it comes with some traits already. There's like one for Scala test, where you just mix it in, and then your build becomes a Scala test build that is pre-configured to run Scala test. Right. So what else would I want to show? Right, and you've seen how. Oh, okay. Let's actually give the test a build file as well. So now in the test folder, we create a build folder, and in the build folder, we create a build Scala. And I'll just copy this over. And by default, it would look like this with test. That's basically the default that CBT uses in itself. But let's not do that. Let's basically write this by hand just to see how this would look like. Because the way, I mean, the test project, it's an own project, but it depends on the other one, right? It needs to compile the other one first and use the class path of the outer one in order to run the test against it. But you can just do this by hand, and that's exactly what this test trait does. So you can have a so-called build dependency, then C, where you say, well, so project directory is a member of this basic build, which just gives you the directory this build is responsible for. So in this case, it would be the directory test. And from there, we want to go one directory up, which is the main stuff. And so now we depend on the main stuff. And in fact, you can even do this, where you get actually, I think it's b.build. This would give you an actual handle to the build object, so you can interoperate with it, call methods on it if you want to do that. But in this case, we just depend on it, which means it's compiled first and we inherit the class path. Right. So, and this is a way how you can basically assemble projects together, right? You have a handle to a different build, and you can kind of create structures how you want. You can do multi-projects build with it. You can have destructure stuff into different projects and have one that's contained and then the other one depend on it. Right, did we actually try that? We didn't, did we? So in that, we need to run tests so that it changes into the test folder and does run there then, which, oh, we didn't configure that to do anything, so it shouldn't do anything, I think. Right. So what do we want to do? Yeah. Oh, actually, it should do something, right? Oh, that's just here. Yeah, so it does. Right. Okay. Few other things. There's CBT admin, which among other things has this. So admin is like, it doesn't call your build. It just does, it's like additional functionality. One of the things is resolve. You can just give it a dependency, and it will resolve it and return the class path, which basically allows you to quickly Scala-cp. I'm using fish shell, so I have these round parentheses to kind of execute this command. Now I can import, yeah, do I have this? Yeah. So you kind of have access to the resolver to just resolve stuff and give you the class path. Oh, one thing I also didn't show, custom tasks. Or, I mean, they're methods, right? And basically what CBT allows you is to call methods on your build object from the command line. And it can also list them. So the default, if you just type CBT, you could just get a help thing. This is the method foo, which I just added to the build. And these are just all the ones that are kind of provided. For example, the provided ones are Scala, version. And I try to use similar terminology to SPT just because to keep it familiar where it made sense. But I can also just call foo. And then it returns this. So that's that. Right, yeah. And I can do stuff like CBT class path, where I do java-cp main. Sorry? No, it's fish shell, it's not bash. Did I remove the stuff? Oh yeah, there's yeah, so you kind of interop with the command line interface, which is kind of nice. I guess that's what I wanted to show. Let's get back to some slides. So to get started, there's a README file. I mean, it's a quick intro I wrote, like a quick getting started. It might even be outdated by now after the changes I did in the last days, but it kind of should get you started. Basically, one fundamental philosophy which drove CBT is builds aren't special. They are just code. They're just another software problem you want to solve. So just write software and do it the same way like you always do it. And I mean, if you need particularly heavy configuration, then inheritance is one thing that allows you to do that. So let's, in this case, use inheritance. The dependencies of CBT itself is Zinc, obviously, Scala, Barbary Watch Service, which is the thing that allows, oh, I didn't show you that. I do that now. There were two things I didn't show you. So CBT, first of all, loop, compile, and actually this -d log allows you to give output some logging. So these are so I'm loop compiling now. It's like the tilde thing in SBT. And these are the paths that CBT watches. And as you can see, well, it's the demo. It's actually the build scripts of the demo. So if you make changes in your build scripts, it will also loop. It's the sources of your project. It's these three things, which is CBT itself. So you can change the build tool itself, and it keeps looping over it and improving. So you can kind of keep, yeah. So let's just change something. Let's change, I don't know, let's change this to, what did we loop? Let's loop run. Does that actually work? Let's see. So let's change this to some random stuff, and let's see what happens. Where did it print it? Sorry? Oh. Right, but didn't I change it to? It changed. Oh, did I run test? Oh, I have to run. Yeah, of course I have to do foo. Right, and let's do it. Something with S in the start. There we go. She runs it twice. That's right. I guess that's a bug. Right. Oh, another thing, just for fun. So let's go into CBT itself, and now I'm going to kill the Maven cache. So now, if I do anything like CBT run, it will need to re-download all the dependencies. And let's log the resolver, so we can see how it just downloads all the stuff. We'll get back to this in a second. Right. It currently depends on Ammonite ops as well, even though it's very, very little. So I'm thinking about just getting rid of this dependency and inlining this, or like doing something similar. So I wrote a custom Maven resolver. So just because it turned out easier than I thought, it was like 30 lines or something, for something that doesn't cover the complete Maven spec, but I yet have to see it to fail. I'm sure there are things out there where it will fail. I heard from Alexander, who develops Corsair, that even Corsair, which does a lot more, still fails on, I think, some Hadoop dependencies or something. But it's not implemented right now, but I had it implemented, but then it kind of fell out, to kind of support to swap in Corsair, which basically would mean you use the simple dependency manager to download Corsair, which works. I tried that. And then you can use Corsair to resolve whatever else you need, which didn't work with the simple one. Right. Oh, by the way, file watching. So Java has its own watcher to watch files. However, on OS X, for some reason, they didn't implement native support for the hooks in the operating system. Instead, they poll every, like, I think 4 seconds, which is kind of a bit slow. So there's this other project, Barbary Watch Service, which basically just implemented that for OS X, and I guess uses the native Java thing on the other systems. Right, you can parallelly execute tasks. It's like opt-in. There's a method which just you can give it the task and you can run it in parallel. Of course, that requires care from you because you do like file system, like I/O or something. If you like write in the same stuff, then it will screw stuff up. There is, however, a feature built in, a tiny caching thing, which allows you to wrap a task into a caching, like basically a caching wrapper, which is thread safe and allows kind of, if you call 2 tasks at once, which both depend on the same task, you can kind of guard them from kind of screwing that up, if you know that that will be a problem. And it will be cached, so it will only be run once. Also, you can use it for expensive stuff. build composition. So really, this is like something like this is what builds look like, right? You have all these kind of little projects which depend on each other, and it's not uncommon that people write large build files for the whole thing, and then at some point it kind of gets unhandy, and then you kind of break it up. But then how people work is that they publish snapshots to like a local Artifactory, and then but that's kind of cumbersome. So I really want something where you can break it up and can publish everything independently if you want to. But usually the way you work and develop is that you have everything kind of together and build dependencies on each other. And then I actually have an or for dependencies where you can say either use the file system if it's there, or else use a Maven dependency, like a combinator on builds. Right. Oh, and this whole dependency stuff, like build composition basically allows dependent build, multi-project builds, having tests as nothing special, just the dependent projects, having builds of builds, and wherever you need like A before B. And actually, it's even unified with dependencies. So most of the code most of the code of a Maven dependency and a build is actually shared between the two, because it's kind of the same thing, right? Provide something before you can do something. This is like the kind of concept that underlies all this stuff. Current limitations. Concurrent builds. So basically, what I do support is concurrent tasks within one build of the kind of lots of builds. What I don't support right now is running several builds concurrently. I do parallel downloads. I don't do parallel builds, because with the parallel builds, you would kind of need to make sure that you kind of compile them in the right order, which I just didn't implement yet, which you should be able to implement. But you have to be more careful that you actually cache correctly, so every kind of build exists only once, and but it shouldn't be a conceptual problem with my model. Right, another problem with the model is, and I think we need some solution for that. So CBT uses inheritance, right? Inheritance is static. So you wire it all together, and then it is wired. And let's say, so how would you do it if you want to provide the Scala version from the command line, if it's wired into this object? Like the build, once it's running, it's like instantiated. How can it swap out its own version number? The other thing is something like, let's say you have one task publish and one task publish signed, or one task publish snapshot. And when you want to publish a snapshot, you want to swap out or append the snapshot to the version number. But it's kind of already wired, right? So there are multiple ways. One is we could just make the classes mutable, like the members, which is probably not a nice thing. If I'm not mistaken, it is roughly how CBT does it, right? Isn't it sort of mutable? Like, I mean, it's a state monad, but it has effects on the rest, right? Or maybe I'm just mistaken. The other thing is you could hard code the use cases that are at hand differently. For example, take the version number as an argument to the class, or put it in the context rather than make it a member. Depends on how far we get with this. I'm not sure. Another thing is use code generation in some way to basically generate subclasses. For the property that you give via the command line, CBT could do that. It could generate a subclass of this build thing which overrides. I mean, it's a build tool after all. It has access to a compiler. It can generate code and compile it at build time, right? Another way would be what I would imagine would be actually nice, kind of create something that's independent, that's kind of reusable, independent of the build tool, which would basically allow you at runtime to mix in stuff. So let's imagine this. We're in the basic build, which is the base class, and then we have publish snapshot, which needs a reconfigured build where the version number is replaced. And then I could say this.mixin and then give it something of the same type that I want to mix in, and it would generate the code for that. So that's still it becomes interesting with stuff like appending snapshot automatically or managing version numbers. So something where still there's room for figuring stuff out. And this, even though it would require like code generation and reflection and all that, it's all at build time, right? So if something breaks, it breaks at build time, not at, right. How to contribute? So it's distributed as source, right? When you use it, you have the source right there, and when you change it, it even applies immediately. So it's very easy to kind of change stuff. There's a very quick developer guide which gives an overview of the folders, which I can actually do here as an unconference session, or maybe even right after in the break or something. And if the code is clean and easy, there's some little superficial craft which just accumulated in the last 2 days while I was like fixing things, but it doesn't like I'm actually very happy with the overall structure and architecture and all that. Right, it rebuilds itself. Extensions are just traits. Put them in libraries on Maven or something, or put them in builds you depend on, which your builds can depend on, right? The build project themselves. Source code later. It would be nice to, right now, all builds need to use the same CBT version. You could imagine that if you want to drop in Scala test or something as a dependency, and Scala test would build with CBT, probably it doesn't use exactly the same CBT version like you do. So you would need to kind of bridge, but that shouldn't be too hard actually. You would need to define an interface, which basically means like, hey, compile yourself before me. That works across CBT versions, they can talk to each other. Yeah, concurrent builds, Corsi integration, actually caching the dependency class loaders are Duo now, which gives a lot of speed up, which actually, if I wouldn't cache the dependencies, the class loaders for the dependencies of your own project, I add minimum a second to the response time. And a second versus half a second is a big difference on like interactive use, right? Oh, I have somewhat of a surprise feature for Scala Day 2016, which I have sort of implemented but not integrated, which is, and GitHub dependencies would be nice. SPT interop would be nice, so you could use a SPT build SA build dependency in your main thing, which would really, if we have that, then it really enables this to kind of interoperate in the Scala ecosystem, right, with the existing stuff. So here's a question that everybody asks: what does it actually mean? So I mean, for me, the C comes from compositional, but there's some of the things that people suggested, because usually people were like, what does it mean? Is it X? And well, there's complex build tool. There's cool build tool. There's CBT build tool because it's recursive. There's composable build tool, which is kind of funny because composable was like my little pun last year at Scala Days for composition possible when I presented the records. What I actually got the most was Chris build tool, so I think I'll actually go with that for now. However, here's an idea I had. So if we manage, like if this gets traction and we manage to kind of make it a community thing, let's in 1 year at any Scala rename it to community build tool. How about that? And oh, a special offer at any Scala, I'll make your CBT builds work if. And what's next? Well, this is beta. Let's go bug hunting. Please report lots of issues and submit PRs, and let's get this stuff solid until Scala Days. And what also is missing is this. So now it's on GitHub. And that's it. Miles.
So there's been lots of talk around
Yes.
There's been lots of talk about getting various kinds of community builds together for things like type projects, essentially. And there's been lots of discussion about what right now substrate to all that is, all that one is things like dbuild, obviously, SPT, options. How do you feel about the idea of maybe building something like that? It seems like it's got very little more, but maybe that's what you need.
Sounds great. I'd love that. Yep. I mean, it should be like each of the projects create a CBT build, and we have some kind of master project which just depends on them, right? And that's it. Yeah, that's it. Rob.
You were talking about something, we talked about this a little bit.
Oh, sorry. So the question Miles asked, just for the camera, type level is kind of looking for some build tool that kind of compiles all of their projects together, and one idea would to kind of potentially build it on CBT. Sorry, Rob.
Yeah, so the limitation that you mentioned with inheritance,
Yes.
immutability, you have things that are kind of set statically. You'd mentioned, well, so would it be possible to just jettison all the inheritance-based stuff and do something just where your tasks are just state monad values?
So
You just take the whole context in and do stuff and maybe modify it and return it.
Right. So
Nothing's static.
So the question was, because of the limitation with inheritance, could you just basically use a state monad instead and use that to compose the different steps and call out to the library? I mean, you totally should be able to do that. It's just a library, right? You just need to build a new layer on top of this library. And I mean, if we go into the source code of, CBT itself and we look into the, I think it's called default build still, should be called basic build. This is really how it looks like, right? You have test, which called out to lib.test. You have run, which called out to run if main found. And you have compile, which called out to lib.compile and just takes all the stuff that has been assembled in that class. And that's some hack I just did. Right, this is probably something that I should put in the library as well. Yeah. Right, more questions? Yes, oh, we need to be done? Oh, one more, okay.
So this is more about like the process of how you designed it. You said that when you asked people who had been involved with SBT, they took a similar approach in the beginning. Are there any problems that they decided to abandon that approach to solve? And if so, how do you solve those same problems?
So I don't know the exact details of their design decisions. I suppose that one of the reasons was this thing that inheritance is fixed and it's harder to reconfigure at runtime. Even though I think it's still fine if you provide a basic building block that's just used by the user where the user can't do anything wrong to basically extend at runtime, at build time runtime, right? I suppose that's it, but also I think SBT, even 0.7 had a handful of concepts which are all subsumed by the whole build dependency concept, or the whole do this before this concept. So maybe there was some complication down this road which actually doesn't exist in CBT. I'm not sure.
Honestly, I'm just curious.
Yeah. Guillaume.
What is Nailgun?
Nailgun. So Nailgun is a library that just keeps the JVM running, and you can connect to it over a service and then start stuff in this. Okay, I think we're through. I'm happy. Do we have a break now, or if people want to see the actual code of the tool in the break or something, I'm happy to show that. It's not going to take long, actually. Okay, thank you, everyone.